Chapter 5 Applications of Integrations. In these chapters, you will be introduced with 3 applications of integrations, which involve the areas under the curve, the volume of solid or revolutions, and the centroid of a plane figure. Without further ado, let us get started. Integrations of functions can be used to determine the area under a curve of the functions. The boundary conditions here is used to determine the range of the areas under the curve. Taking these figures as an example, the functions is given here as y equals to fx. The area that we are interested is ranging from point A to point D, and we are referring to the shaded area which is corresponding to the x-axis. From the curve here, we know that the intersections of the function y with the x happens at point B and C. In order to determine the area under the curve with respect to the x-axis, we can use the methods of integrations. You know that integrating the curve here from A to B will give you a positive value, while integrating the curve below the x-axis will give you negative value. To determine the summations of the shaded area here, you will need to neutralize the negative value below the curve. That gives you integrations of the functions from A to B here to be minus with the functions from B to C, and to be added up with the functions from C to D. The summations of these functions will be equals to total shaded area of E, F, and G. Let us try examples on this. You are given the functions y equals to x power 3 minus 2x squared minus 8x. You are asked to determine the area between the curve with the x-axis. To solve these questions, first you need to sketch the layout of the curve. Find the intersections of the curve with the x-axis by taking y equals to 0. Factorize the functions here. You will get this, and you know that your x will be equals to -2, 0, and 4. If you plot the functions over the range of 0.2 to 4, you will get this curve. These are the areas which is between the curve and the x-axis. To determine the area, you will need to integrate the functions from the -2 to 0 plus the functions from 0 to 4. You know that the integrations of the curve below the x-axis will result in negative value. You will need to neutralize the negative value by putting a minus in front of it. This gives you integrations of the functions from -2 to 0 minus the integrations of the functions from 0 to 4. Solve the integrations and substitute the boundary conditions. Substitute the upper boundary and minus with the substitutions of the lower boundary. Same goes to the boundary conditions from 0 to 4. Solve the equations. You get 49 1/3 square units.